And on to number 11. This is an interesting problem because what we're trying to do here is find the composition, right, of f and g at 5. So we know what this means, right? F circle g, there's a meaning for that. Let's write it. It means f of g of 5. F of g of 5. F of g of 5. Now, let's look in here. We're going to start with a 5 and we're going to apply g to it. Now here's g. Here's the g rule. So the input, right, x, the input is x, that's 5. And the output, g of 5, is right here. G of 5, that's a 7. So now we're here. So now we're going to have f of 7. Okay, let's be sure we see where that came from. What we want to do is compute f of g of 5. That means that's f of g at 5. Now the input is 5, so we're going to go over to the g rule. Here's the g rule down here. So find the input of 5. Here's the input. There's 5, and the output then is 7. So g of 5 is that 7. Now what do we do with the 7? Well, we apply the f rule. Now the f rule is up here. So let's find 7. Here's the inputs. 7 is right here. So when the input is 7, f of 7 is 9. So we're going to get that 9 right there. So now we're going to write this as 9. So all in all, down here, f of g of 5 is 9. Let's just retrace what we did here. So we want to start with 5, apply g, and then apply f. So we start with a 5. Let's do it like this. We start with 5, and we apply g. So here's the 5. We apply g. That gives us a 7. And then we take the 7 and apply f, and that brings us down to a 9. And now here in problem number 12, we want to find the greatest common factor of these three terms. So we're going to look, first of all, what's the smallest number, what is the biggest number that divides into 12, 18, and 36? So just from our knowledge of arithmetic, we know that that's going to be a 6, so we're going to write a 6. And then as far as the variables go, we're going to look for the smallest exponent. So there's 4 x's here, 6 here, and 9 here. So there's at least 4 x's in each one, and the 4 is the smallest exponent. So we're going to write x to the 4th. And then for the y's, we've got 3 here, 5 here, and 4 here. So there's at least 3 y's in each one of these, and 3 is the smallest exponent. So we are going to write y cubed. In number 9, this expression here, is it factored or not factored? Well, factors are parts of multiplication. You can see what you've got here is an addition. So this particular expression is not factored. Let's go to 14. In 14, what we're going to do is factor this. So what's common to both is a 7. And there's 2 m's here, and the smaller exponent is a 1. So we're going to take out a 7m. And then if we do that, what's left? Well, there was a 7. We removed it. There were 2 m's. We removed 1. So there's 1 m left. And then the question is, what do we put here? So 7 times what is going to give us negative 21. So do a little division. Negative 21 divided by 7, negative 3. And you can see that there was an m, but we removed it, so we've got it. In 15, what's common between the 12 and the 16? It looks like a 4, and that's going to be a 4. And then we have x cubed and x squared. The smaller exponent is the 2, so we're going to take out the x squared. Right, we've got 2 x's here, 3 here, so we've got at least 2 in each one. So we'll take out an x squared. And then for the y's, we've got 2 here and 4 over here, so there's at least 2 in each one. So we'll take out a y squared. And then what's left? Well, 12 divided by 4 is 3, so we'll have a 3. And then, what else? There were 3 x's to begin with. We removed 2, so there's 1 x left here. And there were 2 y's. We removed them both, so just the 3x. And then let's come over here. 4 times what is going to give us that 16, so do a little division. Positive 16 divided by positive 4 gives us a plus 4. And there were two x's. We removed both of them, so there's no x's left. There were 4 y's. We removed 2, so there's going to be 2 y's left. And on to 16. You can see this 2x minus 7 appears in both those terms, so let's take that out. So we're going to take out that 2x minus 7, and then what's left? Well, if you remove the 2x minus 7, there's a 3x left and a plus 2. So we're going to get a 3x and a plus 2. In 17, now as you look at 17, there's nothing common to all of these, but we do notice that in the first two, there's an x common, and in the second two, there's a 7y and a 7y in here. The first term in the group is positive, so we're going to take out a positive 7y. So if we do that, take an x out of the first two, we'll get an x, and what's left? Well, there were two x's to begin with. We removed one, so there's going to be an x. And then here, a 4x, we removed the x, so there's that plus 4 left. And then we're going to take out that plus 7y, and if we do that, what's left? Well, here's a 7xy. If we remove the 7y, there's an x left. So we'll take out be left with that x. And then 7 times what is going to give us 28. So a little division, 28 divided by 7. Positive 28 divided by positive 7 is positive 4. And there was a y, but we removed it, right? We removed it. And now you can see, which is what's supposed to happen, right? X plus 4 is common. We're going to factor that out. And what we're left with then, if you take the x plus 4 out, you're left with that x. If you take that x plus 4 out, you're left with that plus 7y. So we're going to be left with x plus 7y. In number 18, nothing is common all the way through, but you can see in this first group, there's a 6 and an x common. And in the second group, now in the second group you've got a y and a y, but the first term in the group is negative. So we're going to take out a negative y. So let's try it. We'll take out the 6x from the first two, right? So take out a 6x. There was 6x squared. We removed the 6. There were two x's. We removed one. So what's left is just an x. And then 6 times what is 24? So 24 divided by 6 is going to be a 4. There was an x. We removed it. So I think we're just going to have an x plus 4. And then onto the next group, take out that negative y. And if you remove the negative y, so you can look at this one here, you have negative xy. If you remove the negative and the y, there's an x left. And then negative 4 divided by really negative 1. Negative 4 divided by negative 1 is positive 4. There was an y, but we removed it. So this is plus 4. And there it is again, that x plus 4, x plus 4. We'll take that out. And if we do that, take out the x plus 4, we're left with that 6x and that minus y. So 6x minus y. In 19, there's nothing common all the way through, so let's write our two parentheses, anticipating we can do this. So to get this x squared, it's going to be the first and the first, so we're going to have an x and an x. Now, how do you get that 40? Well, there's several ways to get a 40, right? What we could do, let's look at it. 40, we could try 40 and 1, 20 and 2, 10 and 4. I'm just cutting in half and double. 5 and 8, and I think that's all the ways. And then what I want to do here is look for what combination of these pairs can I get a 13 out of. So if I add or subtract, 40 and 1, I can't get a 13 out of that. 20 and 2, that's not going to work. If I add, I get 22. If I subtract, I get 18. 10 and 4, 14 or 6 if I subtract. But 5 and 8, If I add those together, I get the 13. I think that's the pair we want. So we're going to write here now, we're going to put in a 5 and an 8, or 8 and a 5. And then we notice that that sign of the 40 is positive. So these two numbers have the same sign. Same sign, same sign. It's going to give us a positive, and that sign is going to be that middle plus sign, so we'll put that in. All right, so we're going to conclude now that we're going to factor this as x plus 5 and x plus 8.